just recap something that we finished with last day, which was a try this question. The try this question had a positive charge and a negative charge that were a certain distance away from each other, 0.6 meters away. And there was a test point that was 0.4 meters from the first charge and 0.2 meters from the second charge. And you were asked to figure out what the electric potential was at the point in between. Well, V total is going to be V1 plus V2, KQ1 over R1, KQ2 over R2. We can express those two by subbing in all the values. Even if we didn't want to factor out the K value, that would be totally cool. The thing is, with electric potential and electric potential energy, you don't want to use absolute values because it is a scalar. So the one charge being a negative value really, really matters here. And it turns out that that charge dominates. Remember, as I was talking about topological diagrams as being a model for this, I'd have this positive charge acting kind of like a mountain and the negative charge acting kind of like a pit. And so we're talking about a point. It looks like whatever's happening here, the point that we're thinking about, this test point, is at a point where it's a little on the lower side than the higher side, if you know what I mean, which is why the answer is going to be a negative answer. And then the follow-up question was, could you find a point where the electric potential is equal to zero? Well, of course you could. You're going to start off with the exact same equation, except the R1 and the R2 value won't be the original R1 and R2 values. You have to come up with a new R1 and R2 value. And so just like pan up to that, or pan down to that, however you want to think of that. We've got our same diagram essentially, but we're choosing a new test point and redefining our R1 and R2. What we could still say is that R1 plus R2 is still 0.6 meters. In other words, the charges are the same distance apart from each other. That hasn't changed. What we could also say is that 0.6 meters minus R2 must be equal to R1. We're just rearranging the first expression to get the second expression, right? And the reason you would do that is that it allows us to express R1 in terms of R2. So that when I take this equation, I say that, I'm looking for the point in space where V total is equal to zero. I'm going to choose R1 and R2 to be my locations. Okay, that's fine. Except instead of writing R1, I'm going to write it as 0.6 minus R2. Now I've got this situation where I have it all in terms of only one unknown. So yes, we've subbed one linear equation into what clearly seems to be a nonlinear equation, but at least like this is nice, right? Like I've got everything in terms of one unknown, which in this case is R2. So then I take, you could have taken either one of them over, but I took this one on the right, the Q2 term, over to the left-hand side, making it negative. Now that that's on the other side of negative, I can cross-multiply the denominators, and I've written in red here the denominators that were cross-multiplied, just so you can follow the logic a little bit easier. Distribute the Q2 through that binomial. Now I've got two terms in terms of Q2, but what I've got is my R2 a little bit more accessible on the left-hand side. Then I can take that term that has the R2 over to the right-hand side, making it negative. Again, I'm using red to code things that I'm doing operationally. And I've got R2 Q1 minus R2 Q1 minus R2 Q2. And of course, the next thing to do would be to factor out the R2. So here we go, the R2 pulled out of that binomial on the right, leaving behind Q1 minus Q2, and then divide both sides by Q1 minus Q2. But oh my gosh, what an adventure, right? So like a lot of thinking going on there. There's a bunch of questions that had this same vein of thinking, whether it's electric potential energy or electric fields or finding the net force equal to zero. This pattern of thinking shows up over and over again, which is why I kind of wanted to walk slowly through it. Well, not so slowly, but at least explicitly through it once. Okay, so I'll post this on the YouTube channel, and if you want to see it like slower, you can see it slower. Okay, but there's also a typed version of the solutions in Brightspace if you care to look at that as well. Okay.